Welcome to the Libertarian Counterpoint. I'm Richard Fields. On the program today, we have Lee Welter, physician here in Sacramento, Tom Tamarkin, who is the president and the CEO of USCL and Energy Site, and Cheryl Bly-Chester, who is the owner of Rosewood Environmental Engineering. Welcome to the show. One of the ongoing issues that we've talked about on this show for a number of years is the whole issue of global warming. Now, I own a couple of farms in Minnesota, and I was at a wedding at which one of my renters was in attendance in April, and he was complaining. You know what he was complaining about?
Cold weather, probably.
Snow, several inches of snow in April.
Yes, well, we're both from the Midwest. My early several decades were
now
in
normally
Michigan.
You've got the oats planted by April, and the corn planted by by early May, but it's still snowing. The actual climatological temperature record for the last decade is global cooling. When will the scare story turn from global warming to global cooling in the next ice age?
As soon as there's money to be had and political power, that's the key to what we're dealing with now, sadly.
Right, we've talked about it before, but the way that research gets done is by who funds the research, and so they fund the research according to what the results are that they want to have. That's how science is done now.
They call it science, but I wouldn't. Would you?
And you're in the scientific discipline.
Right, in the environmental discipline too.
Yeah, and so you're speaking from within the fraternity, so to speak.
Right. You get your funding. You don't propose on grants, and you get your funding according to who has the funding to give and what kind of answers they want to find. If you're not proposing research that's going in a direction that they want to see happen, then you're not going to get the funding to do it.
Have we progressed at all since the age of Galileo, when you couldn't get research for anything other than a flat Earth?
Right. Well, it's the same sort of deal. The people with the money and the people with the power, the people who have the power to put your career under if you don't toe the line.
And it has happened many a time. It's sad. I had an old tennis, well, I guess I could say old, he's now deceased, but a tennis buddy in Ann Arbor, Michigan, at the time head of the Department of Climatology and Oceanography, something to that effect, then went to his native Denmark, where he was in charge of all things meteorological. He objected to some of the, what I call the cult of gullible warming, and he was abused, terribly harassed, and I'm sure under stress may have led to his demise. Yeah, that was the late Axel Wynne Nielsen. And there are many others. There's a very fascinating book written by Lawrence Solomon titled The Deniers. Talks about eminent scientists, what their own view is. And they didn't have an axe to grind. They weren't pushing one agenda or another. They were simply dealing with their knowledge of the facts and the evidence. And one of the eminent Russian climatologists said, we're on the cooling phase right now. Temperature is gradually lowering. And as you pointed out, at some point we're going to be worried about when's the ice age going to
develop us? We were worried about it in the 70s.
Yeah, when Earth Day originated back, what was it, 30, 40 years ago, that was the cause célèbre back then was global cooling. People were worried about the next ice age.
Yes.
That obviously changed, and is the sunspot theory probably a whole lot more accurate than the carbon dioxide theory as far as?
Yeah, there's evidence that that's not even accurate.
Really?
That it could be due to just natural forces like the Earth slowing, the Earth's rotation slowing.
But there are other questions.
Causes friction in the molten. I mean, there's lots of
That's
theories.
true. And there's the other question is why is it that the temperature of Mars has been increasing, not necessarily in parallel, but somewhat similarly to that on Earth?
Well, why has the ocean floor been heating up from the bottom up instead of from the top down if it's really atmospheric? So, that's where it's something in the Earth's core that's happening as opposed to something in the atmosphere.
Yes, but then we have the political explanation. We had somebody who, as vice president, did what he called reinventing government, right? Look what happened.
That's
Well,
right.
keep in mind the fact that the Earth is 4.5 billion years old.
And we're
And
slow.
I'm only 60, barely. And being only 60 years old, what is my reference point when I look at these cyclic changes? What is our human reference point, our human experience over the last 100 years of collected data, or even 500 years of collected data, given the geological age of the Earth?
The more,
To me, these things are cyclic, and we can debate if it's an 11-year cycle or a 60-year cycle or a 600-year cycle, but we know all three of those cycles, in fact, exist, and they relate to activities on the sun, as you mentioned, and they relate to the elliptical nature of the Earth's orbit and the precession of the Earth and complex motion, a lot of which was actually defined by Johann Kepler some 400 years ago.
And I'm guessing that they, to a certain extent, depend upon on greenhouse gases, but probably less than people think.
I think we may have climate change, but climate change could be different than global warming. Climate change can be localized weather patterns of winds and the like. Part of it even can be related to the continental drift and the fact that our oceans are actually changing in terms of their relationship and position on the Earth. It's a very complex project, and quite frankly, I think our money would be much better spent on solving energy as opposed to worrying about global warming, which we can't prove one way or
Well,
the
it
other.
wouldn't have to
Because
be
if we
energy or not.
correctly solve energy, we take global warming as a function of carbon dioxide emissions off the table.
well, we need
Tell
to,
us how we solve energy then.
Well, we solve energy by developing alternative energy sources that are real,
And your favorite
such as
alternative?
nuclear,
Okay.
nuclear fission and nuclear fusion, which are the absolute greenest sources of energy we have. Why? Because they produce massive amounts of energy and no greenhouse gases. And in the case of fusion, no radioactive waste.
And we talked a little bit about fusion last week. Let's do a wrap up on fusion. How is it going to? Where will fusion first materialize as a workable technology, in this country or elsewhere?
Well, I would like to say in this country. And I would like to see it happen in this country, both in our national laboratories, such as Princeton and such as Lawrence Livermore, Sandia and Los Alamos, and perhaps even some private sector enterprises. As I mentioned last week, Lockheed Martin is working on fusion. Several other companies are. But unfortunately, the Chinese realize that this is the only alternative. They realize that coal is limited. And therefore, the recent government of Chinese, the last premier, I was in China a year ago, when the announcement was made that their intent is to graduate 2,000 PhD level engineers over the next 6 years to specifically focus on the development of fusion power over the next 2 decades.
You are going exactly where I was going to go, which is
they are committed.
We have
because they understand it's the only solution.
Very scientifically astute people in China, not to mention India, the
India
Soviet
is number
Union,
2, and South Korea.
and South Korea and
Absolutely.
Israel. Who will win the fusion race?
The country who will win the fusion race is the country that has either a top-down centralized government control that demands it and funds it and makes it happen, such as China, or a country such as ours, a democracy with a large number of people, where the people demand that it happen. But the people can only demand that it happens if they have this knowledge, which today our citizens don't have.
What does it take to educate people that a solar panel is not the equivalent of a nuclear plant?
or even a solar field is not. And can't
Well,
be.
from a scientific standpoint, we have to talk about something called energy flux density, which talks about how much energy, how many joules of energy or watt seconds we get per cubic meter. That's a scientific concept. The bottom line is that fossil fuels such as oil, petroleum, and coal have a very, very dense flux density. We measure it in something called megajoules, or millions of joules per meter cubed. Whereas solar is the exact opposite. We talk about microjoules, or millions of a joule per cubic a centimeter of solar. or cubic meter, I should say, of solar. However, in order to distill this down to a level that people, citizens, will understand it, that's very difficult to do because, unfortunately, our country, in my opinion, has lost its way in education, specifically in science and math, over the last 20 years. So people today do not have the attention span to really listen and study this issue, but rather they rely on sound bites and what their politicians are telling them, which are typically, as you mentioned, controlled by the green energy.
Are you saying that we're graduating too many philosophy majors and too many social studies majors and too many music majors and too many social work majors?
And I won't mention attorneys.
I think it's even
Too many attorneys,
Who's
yes.
getting funded?
I think
Exactly.
I think it's even
Well, certainly the people who are graduating in political science aren't really getting funded.
yes, but I think it's even more fundamental than that.
I guess the fundamental question I'm asking is education the least, the path of least resistance for the student at this point. China has, Japan, India, they make sure that their students learn the hard sciences.
They are motivated.
Here, it just doesn't happen.
Well, we've gone from number 1 in the world in terms of science and math education in the 70s to number 24 or 25
Yes,
today.
but just neglect science and math. Look at
who's
fundamental education. We have a kindergarten through 12th or through 14 system that is a monopoly controlled by politicians.
And unions.
And the unions control the politicians
Absolutely.
in essence.
Right.
Exactly. The model
National
for
Education Association and the AEA.
the model for that school system was the 1819 Prussian mandatory schooling, which was designed to produce obedient military officers and middle managers, the minions for the elite at the top of the pyramid. We don't want to do that, but the politicians want to do it. I don't know why. They love the power, but I resent it dearly.
Welcome to the Libertarian Counterpoint. I'm Richard Fields. On the program today, we have Tom Tamarkin, the president and CEO of USCL, an energy site. We'll be talking to him about nuclear fusion later on in this program. And we have Lee Welter, a physician. I guess we can talk about nuclear medicine, maybe? I'm not sure.
All kinds of things.
I just kind of sprung that on
Weird
you.
and wonderful.
And then we have Cheryl Bly-Chester, the owner of Rosewood Environmental Engineering. I don't know if you do anything nuclear, probably discover nuclear
I
waste.
actually worked in the nuclear industry for a while, yeah, during Chernobyl.
During Chernobyl, okay. What did you do?
I worked for the company that was on Ronald Reagan's team Secretary Harrington's team that went to the summits to talk about Chernobyl, and they sent me to MIT to learn about nuclear power. I was working on nuclear power plants at the time.
Okay, good.
Wonderful
So we got
thing.
all kinds of nuclear expertise other than myself. I have absolutely
Just
none.
barely.
We're in a situation where government at all levels, federal, state, and local, is revenue hungry, primarily because their government is trying to do too many things that cost too much money. And we're getting to the point where a government overkill is taking in something like 50% of the economic lifeblood of the economy as a whole. And at the same time, we're looking at have been looking at an era of increasing energy costs, which in a sense functions as a tax on the economy as well. The more you spend on gasoline, the more you spend on heating oil and so
Right.
electricity and so forth, the more you have, or the less you have to spend on other necessities. One of the solutions that's been kind of out there in the ether, but never really fully developed, of course, is nuclear. Tom, tell us what it takes to get nuclear fusion, as opposed to nuclear fission power, developed and into the mainstream and implemented.
Nuclear fusion is an alternative approach to create a conversion of mass into energy per Einstein's formula of E equals mc squared. E equals mc squared is the special theory of relativity that says a very small amount of mass is equal to a tremendous amount of energy. E energy is equal to the mass times c squared.
And
C
C stands
is the
for?
velocity or the speed of light, which is 300 million meters per second. You multiply that times itself, and the number is roughly 10 to the 16th power, a very large number. So this, in fact, equates to something very small, such as 1 gram of matter, having an equivalent amount of energy as to 7,350,000 gallons of gasoline if you could do the conversion with 100% efficiency. Now, does it work? Yes, this is how the sun works. Our sun is a nuclear fusion reactor, as are all stars. The sun converts hydrogen into helium, specifically 2 isotopes of hydrogen into helium. Can that be done here on the Earth?
It has been.
It has been done.
If my name were Edward Teller, I'd prove to you that it happened.
Or his counterpart in Russia in the 1950s, Andrei Sokhovich. And the fact of the matter is most of the research to implement fusion has been done, unfortunately, in the military, and this is how the thermonuclear bomb or the hydrogen bomb works. That is a fusion reaction. I think I mentioned here 2 weeks ago that in 1961, in October, the Russians detonated a bomb. It was called Tsar Bomba.
How prophetic.
And Tsar Bomba was the largest nuclear reaction that we've ever triggered at one point in time. It released enough energy to power the entire city of Las Vegas for 3 years. However, it released it in a period of time of about a second. It literally vaporized the desert island. Now, obviously, from a weapon standpoint, that's a very efficient weapon. However, to do that to create power for civilian use, this has to be sustained over a long period of time, meaning minutes, hours, days, weeks, and months. You can't just release a tremendous amount of energy instantaneously.
I mean, if you go down to a milligram, would that be one way of getting at the attacking the problem?
Well, the way that you attack the problem has to do with what we call confinement and actually controlling the reaction. It can be done in a very small amount, as you say, with a smaller amount of material over what we call a repeatable period of time, what we call a repetition rate. So if we have a very small reaction, say once every 10th of a second or 10 times a second, then the aggregate amount of that energy can be stored as thermal energy and converted into, say, electricity.
That's the key.
Mechanically.
Yes, electromechanically.
Yeah, right.
That can also be done directly through a process called magnetohydrodynamics. But if we look at the way that we're going to implement fusion in the very short term, it's done thermally. Magnetohydrodynamics is like, once we figure out how to sustain it and we can commercialize it, it's like in the old days in technology when we developed the vacuum tube in the early 1900s. Later that vacuum tube was replaced with transistors and integrated circuits. So the trick is to demonstrate this in what we call a controlled reaction in a contained environment. Prove that it works.
Is the containment the limiting factor right now?
Containment is one of the limiting factors. And the gain factor, it takes a tremendous amount of energy to actually trigger the energy. And in the case of a thermonuclear weapon, you actually use an atomic bomb to trigger the fusion reaction, the hydrogen reaction. Right. So it takes a tremendous amount of energy in a very closed space to actually trigger the binding cohesion of the fusion reaction.
So my simple-minded understanding is that the reactants, deuterium and tritium, 2 forms of hydrogen, have to be very densely compacted at extremely high temperatures and consequently pressures without destroying the container. Is that simple-minded enough, or is it, how inaccurate is that?
Well, it is highly accurate in one form and very inaccurate.
Good. I'm glad we have an expert here.
As in most things, we have 2 polar camps or 2 polar approaches to actually contain fusion. One has to do with what we call a magnetic bottle effect, using something called a magnetic tokamak. And in that case, the pressure is extremely low. We have another approach, which is called inertial confinement, modeling the sun, where you have a tremendous amount of gravity to meet the confinement. And in that case, we use a very, very high-powered series of lasers to trigger the fusion reaction in a very, very compressed fashion. And the difference between the pressures is almost 12 orders of magnitude, or 1 followed by 12 zeros.
Huge.
Yes.
Which one has the better chance for the containment, to sustain a containment?
Well, that depends on who your boss is and where the money's coming from.
Oh, I get
Who
it.
is
Who's funding the research?
The inertial confinement approach is coming from the military side of the equation and a group called the NNSA, or National Nuclear Safety Administration, and is a holdover from the Strategic Defense Initiative, or Star Wars, hence the emphasis on lasers. And it is this approach of inertial confinement that's received the largest share of the budget over the last 15 or 20 years, because it can also be used for nuclear weapons maintenance, what we call stewardship of the stockpile. The magnetic approach, on the other hand, is an approach that may be, depending upon your philosophy and your background and your experiences, more appropriate to produce energy. But it has not had the amount of budget and resources put into it because it is not part of
The defense.
Is all the money that's being spent on fusion research government money, or are there private players?
Well, that's a very good question. There is currently a mindset in our administration, in both the executive level and the Department of Energy, which has basically stripped or gutted all of the fusion budget in the United States for civilian development of fusion power, and has put the money that we would have spent in America with our labs, like Princeton Plasma Laboratories, doing magnetic confinement, into a project in the southern portion of France called ITER. ITER is a project that is being run by the United Nations, of all people. If you can imagine putting the UN in charge of solving energy. And the United States
That doesn't make me comfortable.
in our wisdom, we have basically dictated that all fusion money on the civilian side of the equation be directed into projects that are part of our obligations as a 9% partner into ITER. And this decision was made approximately a year ago by Secretary of Energy Chu and his underling at the time, Dr. Kuhn. And that decision stands. And as a result,
So you're telling
$400 million a year, of which the government expenses is very low, and all of that money is going towards this project in ITER, which is not even scheduled for a demonstration test reaction until 2028.
Now, let me get this straight. You're talking about the French doing something under the auspices of the UN, and that's where our money is being spent.
We're talking about a project which is an international consortium of 9 countries, of which the United States is one. That includes Europe, South Korea, China, Russia, India, and
I'm not optimistic.
Japan.
Going back to the whole issue of
Funding.
Obviously a lot of money is being spent overseas by the UN, by the
Well, not by the UN.
by us, but by the member countries.
By the
By the
member
9
countries,
members.
By the 9 members.
Yeah.
So-
Who are the other members?
Well, I mentioned a minute ago, the United States is one, the European Union, India, China, South Korea, Russia, and Japan.
Okay. Is any money being spent privately anywhere in the world?
In the United States, a number of companies are engaged in private research. Most recently, Lockheed Marietta has announced a project that they're doing in what they call skunks work. And
Skunk Works.
Works,
It's typical for
division
their
actually is in
experimental.
Lauderdale, California.
Right.
Aircraft.
And
It's for we're making UFOs.
No.
Probably.
They're talking about a magnetic containment, a tokamak approach to fusion. Now, how well funded it is and therefore how legitimate it is, we don't know because it's something I'm talking about. But if you do a Google search for fusion and Lockheed Martin, you'll see this.
Okay, so Lockheed is doing some research. Presumably they have a profit motive involved there someplace. I'm assuming they figured that they'll be able to actually build a fusion reactor at some point.
He who controls energy controls the world. So obviously, if a private country can control energy by having a lot of what we call intellectual property, patents, and know-how that is a part of actually creating this that has a tremendous return on investment.
Now,
Because over the next 100 years, you're looking at probably $400 trillion worth of value that could be generated from this.
Regardless, I think the economic incentives are clearly in favor of hydrogen fusion power. I mean, it's a fantastic goal, and I still have.
well, what are the economics on fusion? How much is it? I mean, obviously we don't know because we haven't invented it or haven't worked out the details yet. But what are the projection on how much it would cost to produce a kilowatt hour of energy using fusion?
Well, actually, and you probably have some insight here, because going back to the 70s and 80s, one of the pioneers in the development of fusion was Westinghouse and General Electric. And Westinghouse, in fact, did a great deal of research and development and effort into projecting costs of fusion power plants. And the cost of a fusion power plant from a capital expenditure standpoint is not much different than the cost of a fission plant. In fact, it could be somewhat less because safety containment issues are less than a fission plant.
Because with fission you have radioactivity, with fusion not.
Precisely, and you have the chance for meltdowns and explosions and things with fission. So if we look at it from a capital standpoint, they're roughly equivalent, maybe even less expensive. However, we still have several billion, perhaps 10 to 15 billion dollars of investment in science and engineering development that has to be amortized into that capital expense.
But we're spending. Is the reality that we're spending that money on solar and wind and
We're squandering too much.
and harnessing the tides?
Well, we're probably spending it saving banks and insurance companies, unfortunately.
It's what I call
But-
green waste.
Exactly.
Green waste.
Exactly.
That's pretty
But the fact of the matter is, if you set aside the capital expense issue of the plant, and you look at strictly what we call the fuel cycle elements, then we're talking isotopes of hydrogen that come from the ocean, deuterium, and we're talking about small amounts of lithium, which is used to breed the third isotope of hydrogen, which is tritium. Those elements are very inexpensive, so the cost to produce electricity and even synthetic fuel oils and synthetic fuel gases from fusion, the cost of the fuel cycle is so low, it's close to zero.
Once you have a fusion reactor or a fusion plant built, do they last a very long time, or do they have a finite life cycle like a fission plant does?
Everything has a finite life cycle, so the
design
objective is to build a life cycle that, again, you can advertise the return on investment out over the first
But what are
5
the-
years,
what are
and
the
then the
projections?
life beyond that is somewhere in the area of 40 to 50 years,
Okay.
which is equivalent to a coal plant or a nuclear fission plant, as we currently know them.
And you started off with the idea of the peak oil. We have a reprieve now that we found these huge oil deposits, right?
One school says that we peaked somewhere in the 1980s to 1990s. The latest school says that we peaked somewhere in the area of 2000 to 2003, and that's
You talking about Colbert?
and that's including what we call
Or Hibbert?
proven reserves as well as technically recoverable reserves. We have peaked. We're beyond peaked. Production can continue to go up, but again, you have a finite amount left. So we can continue to increase production for the next 10 years, but then after that, we have a very shallow declination.
I think that financing the
By
research.
2030, we're in trouble. Put
I
it that way.
think financing the research is another concern. For example,
That's another topic, and we'll do that on another show. Thank you very much for being part of the show. We'll see you again next week, same time, same place, 8 p.m. Thursday, noon Friday, 4 a.m. Saturday. www.accesssacramento.org is where you can find us on the web. Thank you very much for being part of the show.